Today, let's go over the chain rule. The chain rule is useful for when you're differentiating two functions. You'd have an f of x function and a g of x function. This is the basic setup for the chain rule. You need to take the derivative of the outermost function, then the innermost function is left alone, then you take the derivative of the innermost function. That's basically it. Let's do some examples. Let's start by differentiating this equation. We have 3x squared plus 4x in the parentheses, and the entire thing is raised to the third power. So this is our innermost function, and the exponent is our outermost function. Now, if we look at this equation, we see that we're also going to need a power rule. A lot of times you're going to need to use more than one method of differentiation to solve a problem. So let's go ahead and solve. First, the outermost function. It's an exponent, so we're going to need to use the power rule. We're going to bring our exponent down in front, and then we're going to subtract by 1. So this is going to give us 3, and then we have our innermost function here, and this is going to be raised to the second power. Now we take the derivative of the innermost function. So again, we have to use the power rule. We'll put it in these parentheses. So 2 times 3, that's 6. X, 2 minus 1, that's 1. So x to the first power. Plus 4. This is our answer. So here I color-coded it. We have our outermost function here. That corresponds to this. We have our innermost function, which is left alone. And then over here, we have our innermost function that we differentiated. Let's do another fast example. Next, we have 5x minus 3, all under a radical. This can be rewritten as 5x minus 3 raised to the 1/2 power. Let's solve this using the chain and power rule. So first, let's take the derivative of the outside function. So we're going to have 1/2, and then we're going to have 1/2 minus 1, which is negative 1/2. Then we have our innermost function here left alone. Then we have to take the innermost function and differentiate it and put it here to be multiplied in. So using the power rule, we bring the 1 down to the 5 times x to the 0, which is just 5 times 1. And then this is a constant, so its derivative will be 0. So on the outside, we have 5, and that's our final answer. Lastly, let's take a look at this one. So we see that our innermost function is 2x plus 3 over 6 minus x squared. We're going to need to use a quotient rule for this, and then a power rule for the outside. So let's first do the outermost function. We have 3, we'll bring it down, and then subtract 1, so 3 minus 1, it's going to be squared. Here in the middle, we're just going to leave it how it is, 2x plus 3 over 6 minus x squared. Now we need to use the quotient rule in order to find the derivative of the innermost function. If you need a refresher on the quotient rule, feel free to check out my previous video where I go over how to use the quotient rule. So we'll do this down here to give us a little bit more space. So first we need to take the derivative of the numerator, that's going to be just 2, and multiply that by the denominator, 6 minus x squared. Subtract that by the numerator, 2x plus 3, and multiply that by the derivative of the denominator. That's going to be negative 2x. And that's all going to be over the denominator squared. So this is our final answer. You could simplify it more, but I don't know. This is what we got. I hope you enjoyed this hopefully quick video on the chain rule. Hope it helped you out. Thanks for watching.